For two-dimensional arrays in C, we use two sets of square brackets to give the dimensions in the declaration, first for the rows and then for the columns. Also, when you're referring to array elements, you have two sets of square brackets. Again, first the row index and then the column index. In C, indices always start at 0, so for both the rows and the columns. And we use nested for loops to perform operations on all elements in the two-dimensional array. Here are some examples of two-dimensional array declarations. So we can declare the array. For example, here I'm declaring an array called quiz to be the type int, so every element in the array is the type int. And we have one set of square brackets for the number of rows and another set of square brackets for the number of columns. So this is a 2 by 3 array of integer quiz grades. We can also initialize in the declaration by giving nested curly braces. So inside of curly braces for the entire array, I give inside of curly braces the values for the first row and then the values for the second row. So we can initialize all of the elements in a two-dimensional array in the declaration. So this is what the two-dimensional array looks like if we have declared it as a two-dimensional array, a 2 by 3 array, and initialized all of the elements. So we have an array that has 2 rows and 3 columns, and again the indices start at 0, so the row indices are 0 and 1, the column indices are 0, 1, and 2. Now to refer to individual elements, we use square brackets, first for the row and then the column. So for example, quiz sub 0 sub 2, so 0 is the index for the row, 2 is the index for the column. So 0 for the row, 2 for the column, gives me this value right here, the element here which has the value of 9. Two-dimensional arrays and nested loops go hand in hand. So assume that we have two constants, one called row and one called col, for the number of rows and columns, and that we have declared a two-dimensional array variable called arrayVar. For example, we could declare it to be the type float, arrayVar, and then this is the number of rows and this is the number of columns. So if we have an array variable like that and we want to do something with every element in the array, then we're going to use a nested for loop to iterate through all of the elements. So we're going to loop through the rows and we're going to loop through the columns. So for example, here I have a nested loop in which the outer loop is over the rows. So I starts at 0 because the indices start at 0, I less than row, I plus plus. And then the inner loop is going to loop through the columns. J starts at 0, J less than col, J plus plus. And then the key thing is that we're doing something in the action with the array variable sub I sub j. So always using the loop or iterator variables, in this case I and j, to index into the array variable, first the loop variable over the rows and then the loop variable over the columns. And that's always the case regardless of the order of the loops. So in this case the outer loop is over the rows. So when is the outer loop over the rows? When is it over the columns? If you want to do an operation for every row, the outer loop must be over the rows. So if we're doing something for every row, then the outer loop is over the rows, the inner loop is over the columns, and we're doing something with the array variable sub I sub j. So again, the row index first and then the column index. If, on the other hand, we want to do an operation for every column, the outer loop must be over the column. So in this case, the outer loop is over the columns, and the inner loop is over the rows. And we're still doing something with array variable sub I sub j. So first the loop variable for the rows, and then the loop variable for the columns. So regardless of the order of the loops, when you index into the array, it's always the row and then the column. So again, if you want to do something for every row, the outer loop has to be over the rows. If you want to do something for every column, the outer loop has to be over the columns. And if you just want to do something for every element, then the order of the loops doesn't matter. So for example, if we had an array and we wanted to add all of the elements in the array together, then we would initialize a sum to 0, then we would have our nested loop, and in this case the order doesn't matter whether we go over the rows first and then the columns or the other way around, but what we want to do is to add each element in the array to our running sum. So we initialize the sum to 0 first before the outer loop because we want the overall sum of all of the elements. On the other hand, if we wanted the sum of every column, so again, if we want something for every column, the outer loop has to be over the columns. So the outer loop is over the columns, and the action now is going to be compound action, because for every column I need to reinitialize the sum to 0 and then loop just to add the numbers within that column together. So the outer loop is over the columns because we want to do something for every column. For every column, we initialize the sum to 0, we loop through all of the rows to add all of the numbers in that column together, and then presumably in here we're going to actually do something with the sum, so we're going to print it out or use it to calculate the average or something like that.